what is, of course, India's roadmap. How are we planning to grow this or take this forward? So you have petroleum, it burns, it gives you energy. Hydrogen is not like that. The problem with electrolyzer is that we are not manufacturing any electrolyzers in India. Okay, using hydrogen cell, they've powered a drone. It's a completely indigenous technology. Every part, every segment is made in India. India is specifically focusing on this. We are talking about green hydrogen, and India is the one who is promoting this on the biggest scale in the world. That our capacity will be immense, and we will be very soon exporting this green hydrogen to all parts of the world. Hello everyone. Today we are going to talk about hydrogen fuel cells. This is one key area where there are a lot of developments taking place, and it is like a very big mission, a very big motivation, something which the government of India is really promoting. In the energy sector, earlier we had solar. India kind of was instrumental in pioneering the whole process of making solar energy a very big initiative, a very big endeavor. And that's the similar thing which they want to do with hydrogen. So we are going to understand the science behind it. We are going to understand how this works, what is the significance of this, and what is, of course, India's roadmap. How are we planning to grow this or take this forward? First, let's talk about hydrogen, right? We all know about hydrogen. This is what your basic hydrogen atom looks like. It is the lightest element in nature. It's the first element in the periodic table. It is also the most abundant element in the universe. If we look at the entire universe and its composition, so it is made up of hydrogen in the highest capacity. Now that means availability of hydrogen will not be a problem, right? So here, the hydrogen basic atom structure. So there is a proton. If you understand basic atom structure, you know about parts of the atom. So you have protons and electrons. So this has one proton, and around this there is one electron. Okay, that's the basic structure of a hydrogen atom. Now, because of this structure, or because of this being very light, its nature is as you know, gaseous. So hydrogen exists as a gas, so it will have a very high volume. There's a lot of volume density associated with hydrogen gas, and movement or capturing it and storing that in that sense is one part which is tricky. Because if something is gaseous and you have to move it around, you will have to either have very large containers, right? Because the gas is taking a lot of volume, so you need big, huge volumes of containers. Or you can liquefy it. You can transfer it in a liquid form. For that, either you need very high pressure, very intense pressure, or you need to bring the temperature to very, very low degrees. Very extremely low temperatures can also help in reducing that volume, and that is what can facilitate or help in storage or carrying of that hydrogen gas. Another point, like we have to talk about the fuel aspect here. So this is something which you need to really know about it. So hydrogen is not exactly a fuel. Okay, a fuel would be something like, let's say petroleum is there. Okay, so you have petroleum, it burns, it gives you energy. Hydrogen is not like that. For hydrogen, the term we use is, this is an energy carrier. Being an energy carrier means that it's not exactly or in that form available. It is available as a part of different things. Like hydrogen would be there in water, hydrogen would be there in ammonia, hydrogen would be there in a lot of natural organic compounds, let's say natural gas for that matter. So it has to be removed from there, it has to be extracted from these sources, and then it can be used as a fuel. Then you will be able to burn हाइड्रोजन और यूटिलाइज इट एज अ फ्यूल, बट वो डायरेक्ट फ्यूल के फॉर्म में ऐसे इट्स नॉट अवेलेबल. Okay, so in that sense it's like a secondary fuel, so we use the word energy carrier. But once it is used as a fuel, it's going to be a clean fuel, because this is, I think, a basic concept which all of you will understand. So hydrogen along with oxygen, so that burning of the fuel takes place in air which has oxygen, and what you're going to get out of it is water. This is the brilliance of this whole process, that the byproduct which will come out, of course, along with this energy, that's why we are calling this the fuel. So the byproduct which is coming out is water. This is the big property which we want to extract by using hydrogen as a fuel. Because the fuels which we are commonly using, the organic compound based fuels, petroleum based fuels, so everything from petrol, diesel, even things like coal, they are all producing byproducts which are harmful for us. You have harmful gases like carbon dioxide, carbon monoxide, then sulfur related gases, and different kinds of fuels also give a lot of particulate matter, harmful material being released into the atmosphere, and the problem which we mainly discuss in the form of carbon emissions. This is, carbon emissions is the biggest challenge to the environment. Development in any sector is threatened because of the fact that it becomes very polluting. It releases carbon emissions that increases temperatures of the world. You have global warming, you have climate change, which are increasing at a scale which is very difficult to manage with the current technologies. So there is a need to have alternatives, and hydrogen in that sense is a very wonderful alternative, because here you have no carbon emission. In using hydrogen as a fuel, like we can make fuel cells out of it. This is also our main topic. We can make these fuel cells, and these fuels will use hydrogen, will use oxygen, and will give you water, which is clean, which is non-polluting, which is non-threatening to the environment. So any goals which we have for the environment, they would need hydrogen. We're trying all kinds of technology which can help us in reducing this carbon emission. And one such very promising idea, very promising technology has come in the form of hydrogen. The only question is, how is this hydrogen being created? Like I told you, it's an energy carrier, it's present in different things, and you have to extract it from there to be used. So that extraction process is very energy intensive. A lot of energy goes into that process of actually getting the usable hydrogen form. So how is that process done? How is energy being used for that creation of hydrogen? That will become the clear deciding factor of what kind of hydrogen we need. So we usually use the methods of production of hydrogen to give our understanding on different types of hydrogen. This is a color-coded standard nomenclature. You give different colors to the different processes through which hydrogen is produced. This is very key for you to understand and know all of this. We'll talk about them one by one. First is black or brown hydrogen. This process, it uses coal, and coal gasification process is used to remove hydrogen. Like I told you earlier also, hydrogen is present in your fossil fuels. So from that we can extract. So in this they are using coal. Coal means there will be carbon emission, there will be carbon residue, right? Then you have gray hydrogen, in which you have methane reformation. Okay, this is going to be coming from natural gas. So natural gas, if you understand, natural gas has many things, but the key component of natural gas is methane. So what they do is they take this methane, or they take this natural gas. Along with this, they give steam at very high temperature, and as a result, hydrogen is produced. This gray hydrogen is the world's most widely used process for producing hydrogen. In fact, more than 90% of the world's hydrogen is produced by this method, the gray hydrogen. The big reason for this is very economical. See, any industrial process which is there, the cost factor would be a very key thing for understanding if it is going to be used or not. And whenever we talk about replacement or changing into another method, one of the biggest barrier comes is in the form of cost. The cost is so high that the industrial process will not become profitable if it is supposed to work like that. So this is the most profitable. Natural gas is available, and in that you can easily produce gray hydrogen. So most widely used process, I told you globally. If I take you to the specifics in India today, almost all the hydrogen which is being produced is gray hydrogen. Okay, so this is the key process. Let's talk about others. Then you have blue hydrogen. So this is coal gasification and methane reformations with CCUS. Now this is what is important. This is what changes. Methane reformation or coal gasification is just black or gray only. But this point is the game changer, which changes it from being a carbon emitting to a non-carbon emitting method. What this means is, very important concept. So this is carbon capture, utilization, and storage. So this in itself is a very innovative technology. This is really being discussed a lot globally. A lot has been talked about it. If we talk specifically about our exam, the UPSC exam, they've also mentioned and taken up this topic in the exam. So what is done is, you take normal coal gasification or methane formation, you will get some carbon emission. But once that carbon emission is there, you have a process to capture that carbon, utilize it, or store it. Okay, there are methods available for that, the technology is available for that. That means ultimately no carbon emission is coming out. So even if carbon emission was there, even if carbon byproducts were there, but you have captured it. So this blue hydrogen also in that sense is a good method, is an environmental friendly method. It will involve a lot of technology intervention because this would need some specific technologies, but on the whole, this is something which should be encouraged, which should be promoted. India is talking about this blue hydrogen also. Then you have turquoise hydrogen. Pyrolysis just means breaking down at high heat, at high temperature. So from methane, we can get hydrogen through this method. Then you have electrolysis. Now this electrolysis is the method which is, you can say in a way, a very common method of producing hydrogen. The electrolysis means lysis or breakdown under the impact of some electrical energy or electronic process. So basically it is electrolysis of water or splitting of water. So water is made up of hydrogen and oxygen. You split it, you get the two components, hydrogen and oxygen. So electrolysis process is another process which is used to produce hydrogen, and in this case it's using the nuclear energy. In nuclear energy also, There is no carbon emission. Of course, nuclear energy has its own challenge in terms of radioactive waste, and management of that waste can be cumbersome, but still a much better method. And the last one is green hydrogen, in which there is going to be electrolysis, but it will use renewable energy. Biomass gasification. Biomass also is a way to capture and use the carbon content. Okay, so in this point is key, that you are going to make hydrogen, but the process of making hydrogen is going to be from renewable energy sources. That means sources like solar, wind, hydro, sources which in themselves are not polluting or damaging to the environment. Now, this one is the most ideal way to produce hydrogen. And India is specifically focusing on this. We are talking about green hydrogen, and India is the one who is promoting this on the biggest scale in the world, because our objective is that we have to start production of green hydrogen, and we will do it in a sense that our capacity will be immense, and we will be very soon exporting this green hydrogen to all parts of the world. Hydrogen will be very useful in the sense of all its properties as fuels. It also has industrial applications, which we're going to talk about. But along with that, this is also a way to encourage renewable energy production. Okay, and we have goals or international targets which we have. Like we have this target of net zero emission. If you go through the world protocols, where we have like the Paris Agreement, so through that, different negotiations have been happening to reduce the carbon emission, and India has set a target of 2070, that by 2070 there will be net zero emission. If we are releasing any emission of carbon, we'll also have ways to reduce that, bring that down, so that our net becomes zero. And if we have to do that, we need alternative sources like hydrogen, and we need encouragement of renewable, non-polluting, non-emission sources, like that is your renewable energy. Now, let's talk a little bit more about this green hydrogen. So, how that whole process of green hydrogen will work. Okay, so the process is called electrolysis, and the electrolysis process will need a special equipment, a special machine, you can say, which is called an electrolyzer. So this is what would happen. See here, just a simple chain of the whole process. So we have renewable electric energy generation. This is the key, like they have windmills here. So wind energy, renewable energy. Then you have to get this energy into an electrolyzer. So you have electrolyzer. This is the machine, the setup where the electrolysis of water will take place. Then once it is produced, once hydrogen is there, then you have to distribute and store it. And then this can be used in different ways, in vehicles, in running different industrial setups, and ultimately that leads to net zero emission. Now, in this process, all the steps as of now in the present state of technology are what are challenging or what are tricky for us. First of all, renewable energy is still expensive in India. Okay, and production is also not at a very wide scale. It's not very reliable as such as a source of power. So that's the first problem with this step. Then you have your electrolyzer. The problem with electrolyzer is that we are not manufacturing any electrolyzers in India. Whatever electrolyzers are coming, they're coming from China. There's a lot of import dependency. That means, again, it's going to be expensive. We have started encouraging production of electrolyzers. It is beginning because the government is emphasizing on green hydrogen, but still, this is a big infrastructure gap in our system. Then storage and distribution, I've already told you. You have to either compress it high temperature, and in that also there are challenges, leakages can happen, or extremely low temperature. So you need again that whole infrastructure to develop that. We use the word cryogenic temperatures, extremely low temperatures, right? But if there are safety concerns if some leakage, some damage happens, because what can happen in that case is, see, hydrogen is very highly inflammable. Okay, so that's the tricky part of managing, storing, and distributing hydrogen. And then, of course, you need equipment. If you're using it in a vehicle, you need compatibility, you need retrofitting, you need designing of like vehicles which can use this kind of fuel or waste to deliver it. The government is doing things in that, like you have a vessel. Recently, the reason why we are discussing this is because it's been in news, as in Varanasi, an indigenously built a vessel which will use hydrogen fuel has been brought in, but still there are a lot of gaps here which we would need to fulfill before this can really become big. Let's talk about its applications. Now I'm going to take you to the applications of hydrogen, not just as a fuel. Of course, as a fuel, it is something which is important. We've stressed on that, but there are other applications also. See, currently, I told you, we are using gray hydrogen. And that gray hydrogen is mainly being used in these two areas. One is petroleum refinery, second is in fertilizer industry. Now, the advantage which these two sectors have, especially petroleum, right? Gray hydrogen is produced from natural gas. So where you have petroleum refining happening, natural gas is already there at that location, right? It's a component of petroleum. So formation, that's methane reformation process, that can take place on site. You already have that. You take out hydrogen from that, and then you can use the hydrogen in different processes of refining, like desulfurization. Like hydrogen can help in reactions which can remove sulfur from these petroleum products. We also talk about other processes, like we say hydro treating, which will help in breaking down different parts of petroleum into smaller parts, and hydrogen can help in doing that. So hydrogen will be used in this process, and it can easily be produced on site for doing all of this. This is one of the key industrial uses of hydrogen at present, which is being done. The second very important part is ammonia production for fertilizers. So hydrogen and nitrogen, right? Nitrogen is another abundant gas. So hydrogen can combine with nitrogen, and that will ultimately give you ammonia, and ammonia can be changed into urea, which is a very key fertilizer. So fertilizer industry in that sense needs hydrogen for production of ammonia and urea. So that's the second area where it is being used currently. So these two industries are already doing very well when it comes to use of hydrogen. The other industries where it is now going to be encouraged or promoted that hydrogen should be used, one would be steel industry. So in steel industry, there is a process of reduction of iron ore. See, iron ore basically is an oxide of iron. Okay, so for us to be able to use iron, we have to remove this oxide, right? And different processes are used to that. Like currently, coal is one of the key things which are used to remove oxygen from iron. Okay, this fossil fuels, this non-renewable source, polluting source. Now there's another method that for reduction of iron ore, instead of coal, we can use hydrogen. So in this way, a very heavily reliable industry, an industry which is very heavily reliable on carbon emission, can actually get itself the freedom of not using the non-renewable polluting fossil fuel. We use this idea, or we explore this as decarbonization. This is a very big goal of the government. Decarbonization of heavy industry. This is what we want to do, that the industries which are heavily reliant on carbon, we have to remove them, we have to give them an alternative, and the alternative is going to be hydrogen. Then, of course, what we have, the next option is in transportation. In transportation, we are going to specially create fuel cells which will use hydrogen and which can be used for different kinds of vehicles as their key energy source. Another option which is being tried in a number of places now in small pilot scales, many cities in India are exploring this idea, which is hydrogen blending. See, hydrogen is a gas, natural gas is a gas. So natural gas is used in many places, like cooking gas, for example. So hydrogen, even if it does not become a complete fuel or a complete source as a replacement, it can be added in smaller amounts. Okay, again, reducing the burden of these fossil fuels like natural gas. So hydrogen blending in natural gas, that is what can be done. That is what can be achieved. Now we're going to go and discuss this fuel cell. What is the mechanics of this? What is the reaction which takes place? How does this fuel cell work? And why is this such a big game changer for us? So hydrogen fuel cell. Simple idea. I'm sure in school everybody studied about cells, where you have to draw those diagrams also. There will be an anode, there will be a cathode, and current will flow from one part to the other, right? So cell, the idea of the cell, the technical logic of a cell or a battery, something which will conduct current, that remains the same. But here we have hydrogen and oxygen. So what's happening here is hydrogen fuel, hydrogen gas basically, that's going to go inside, and this gas will leave, it's going to break down basically, and the electrons will come out, and what will be left will be a positive hydrogen atom. So it's just one proton, right? The composition of hydrogen atom is one proton, one electron. So if the electron goes away, then what's left is one proton. So this is there at the anode. At the cathode, you have air coming in. And the key component of the air which is going to be involved here is oxygen. So oxygen is coming in and it's going to react with the hydrogen ions which are present, and that is, there's like an electrolyte, there's a medium here, and that will give you, the reaction will give you water. So whatever excess hydrogen is there, that's going to go out. Whatever excess gases is there after the oxygen is used, that is coming out from air, and the water, the clean byproduct of the reaction, that is happening. The electron which is here, it's going to pass on here, complete the circuit, and that's how current is going to flow. Current, electrons flowing is what basically is going to produce current, and this is your hydrogen fuel cell. Now in this, you have these membranes also in between, which are going to like help in creating barriers and allowing things to move across. So in terms of design, these membranes are a very big problem for us. So we have these proton membranes, we call them, okay, these ones. These membranes, we cannot, or at least as of now, we are not making them indigenously. So even if we figured out a lot about the design and we are trying to do a lot of research, this is one component which we are importing specifically in all cases because we are not able to create this on our own. So I'm stressing out the challenges, the hindrances in each step with you so that you can connect with the overall picture. Now let's see the advantages. We've already stressed about this, but let's see if you're using hydrogen fuel cells. So because this is convenient in size, in operation, it can provide energy for a very long duration of time. So it becomes a very ideal thing to be put into vehicles. Different kinds of vehicles. It can be the naval vehicles, or it can be land vehicles, trains. So in all of that, we see application of this. So क्लीन एडवांटेज सबसे पहले क्लीन है बाय प्रोडक्ट वाटर है देन another thing is its operation is very quiet. There is no large scale engine chattering I would say which is involved here, so it is a very quiet operation. And then of course reduces fossil fuel dependence. For a country like India, that means less imports because majority of our fossil fuel is an import. We have a lot of dependency on that. So if you have something which you are going to be producing in, so dependence on that, especially because there are damages which are going to be happening because of using of fossil fuel. So this is a good alternative which we have. But of course there are challenges. I've spoken to you about all the challenges. I'll just list them together, summarize that for you. First is high cost of renewable energy, right? Then there's a storage problem. Then I've already told you this is highly inflammable. Infrastructure gaps, we are not making electrolyzers. So if you really want to improve our production of hydrogen, the green hydrogen, so this is not just hydrogen, but the challenges are specific for green hydrogen. Because we don't want to do any other kind of hydrogen. We want to do green hydrogen. That's the way to go. And if we talk about development or advancement in any sector, at this point of time where the world is placed, it's important that sustainability factor has to be considered. And that is only happening with green hydrogen. Then you have another key point, which is the need for demineralized water. Okay, you need water to electrolyze because you have to split water and then you get hydrogen. Now, this water is an issue in many regions. Like if you want to set up electrolyzers, you have to think about areas and their issues of water scarcity. There are a lot of areas in our country where having regular drinking water itself is very tricky. So you cannot really have water in a large scale for industrial applications. So water and availability of water in a particular region, and demineralized water means that using ocean water, sea water will be very difficult because it is loaded with minerals. So in that sense, this point will have to be a very important point for consideration of setting up this whole hydrogen manufacturing in any particular area. This is another challenge to the process. Now we'll talk about the government initiatives. I have told you that government is really encouraging this, and the seriousness of the government can be felt from the point that they have a dedicated mission, the National Green Hydrogen Mission. This is a very big deal. This is something which could be like directly a mains question for you, a prelims question for you. It's an important theme. There's a lot of promotion of this. The Prime Minister talks about this in all kinds of energy conventions, energy forums. So let's see what this is. So duration is phase 1 is it's like this program probably started in 2023. So that first year 2022 to 23 till 25-26, that was the first phase, and there's another phase 26 to 27 and finally it's going to end in 2029 to 2030. So the mission period is till 2030. And what is the objective? The objective is to make India a global hub for production, usage, and export of green hydrogen and its derivatives. This is the goal. Even now, India has one of the largest production and export of green hydrogen, but they want to really increase it further also, because this is an idea which they are really pushing behind, and it works very well for India's unique case, and it can be a very big way of getting revenue also, getting economical benefit also, because export here is one very key target. If this program, if this plan becomes a success, instead of India being an energy importer, right? We are currently an energy importer and energy dependent country. India will become an exporter of energy. Okay, that's the goal, that's the aspiration which we have set with this mission. There are some programs, in fact, 2 key programs under this mission, which I want to specifically highlight for you. You should know this. Okay, this is complete, I would say, ready-made content for you for answering any kinds of question on hydrogen. You'll be ready. But this, yes, you should note, you should know. So, strategic intervention for the Green Hydrogen Transition Program site. So this is a program site which is for incentivizing the domestic manufacturing of electrolyzers. So the first phase was mainly about site. Okay, I told you there are 2 phases, right? We just saw that in National Green Hydrogen Mission. So first phase जो है उसका focus है set electrolyzers. Even if we start producing green hydrogen and electrolyzers are being imported, like I told you, electrolyzers would come from China. So it would mean a lot of cost. It would mean that it would be very expensive. So we don't want that. So if you want to reduce cost, you have to do this in-house, because again, that challenge of import dependency would be there otherwise, right? So site talks about domestic manufacturing of electrolyzers. First you set up electrolyzers, then you make green hydrogen from that. Then the government is specifically setting up green hydrogen hubs. So there are regions which will be developed, which will be centers for large scale production, utilization, and ultimately export of green hydrogen. Now there are 3 such green hydrogen hubs which have been set up. So you have one in Gujarat, the Deen Dayal Upadhyay port, the Kandla port basically, that has been created as a green hydrogen hub. Then you have one in Tamil Nadu, the VO Chitambram port, and in Orissa, the Paradip port. Why ports? Because ports in themselves are like autonomous units. They can have their own energy production. You need to fuel them. You need to have some kind of an economic engagement also. So from their export facilities can work out very well. So because of this, these are the first 3 green hydrogen hubs which are being developed. Along with this, time and again, we keep reading about different initiatives, different innovations, private or public government levels, that will give you an idea about the developments which are happening. So I have 2 more examples picked up here for you. One is that in Haryana, there is a hydrogen drone. Okay, using hydrogen cell, they've powered a drone. It's a completely indigenous technology. Every part, every segment is made in India, and that's going to be launched. So another innovative application. Then you have India's first indigenous hydrogen fuel cell. This is a passenger vessel basically. So it's going to be running on water, which is being set up, which is going to be beginning in Varanasi. So these are real life application of an idea, and very important topic from the point of view of the exam. I hope I've been able to help you out with all aspects of hydrogen. I wish you all the best. Thank you.